This lesson is Properties of Logarithms. This is a page right out of the book. Go ahead and pause the video here and give that a read. Alright, properties of logs. Log base a of 1 will always equal 0 because a to the 0 is 1. Log base a of a will always equal 1 because a to the 1 is a. So that's our first two properties of logarithms, things that are always true. Here's some theorems. If m and n and a are positive real numbers with a not equal to 1 and r is any real number, then the log base a of m times n is the same as the log base a of m plus, notice the multiplication went to addition here, log base a of n. That's an interesting thing about logs. A product can turn to a sum. Kind of different. Log base a of m over n is the same as the log base a of m minus the log base a of n. So a division turns to a subtraction. It's kind of the same symbol, they just mean different things, radically different things. A couple more. Log base a of 1 over n is the same as the opposite of log base a of n. So 1 over n is the same as just negative log base a of n. Log base a of m to the r, this is a very useful one, is equal to r log base a of m. So it's like this power can fly to the front of the whole log, and it just makes everything easier to work on. Now I just have to be able to figure out log base a of m and then multiply the answer times that value r. So that power kind of flies to the front of a log. That's a really helpful thing. We're going to write this as a single logarithm. So I've got log base a of 7 plus 4 times log base a of 3. Well, I know the 4 can fly to the front, but that also means it can fly back to here. So that's log base a of 7 doesn't change, plus log base a of 3 to the 4th. So the 4 came back up as a power. 3 to the 4th we can evaluate to 81. Remember, a sum is really a product. So this should be log base a of 7 times 81, which is 567. So here's my single logarithm. I went from 2 logs to 2 logs to 2 logs to 1 log base a of 567. Here's another one. 2/3 log base a of 8 minus log base a of 3 to the 4th minus 8. Well, the 2/3 can fly back up. 3 to the 4th is 81. We're going to subtract that 8. Let's see, 8 to the 2/3 is 4. 81 minus 8 is 73. And remember, when we see subtraction, that's really division. So log base a of 4/73. This doesn't reduce or divide nicely, so we'll just leave it alone right there as a single log of a. You try. Here's a nice big long, got 4 logs going on here. See if you can get that down to a single logarithm. Press pause. When you're ready to check your answer, press play. Alright, log base a of x we can't do anything with. Log base a of 9 we can't do anything with. Can't do anything with any of these individually. So where it's plus, we're multiplying. Where it's subtract, we're dividing. So we have taken log base a of x plus log base a of 9 and made that log base a of 9x. We have taken the 9x1 plus the x squared plus 1 and it's made that 1 log base a of 9x times x squared plus 1. We still have that subtraction, which means we're going to be dividing by 5. So we're multiplying all the positive ones together and dividing by the negative 1. We could distribute the 9x and get 9x cubed plus 9x all over 5. We've got the log base a of that. Here's a few more for you to try. What's this first one? Log base 7 plus log base 2. Log base 14? Actually, log of 14. When we don't write a base, that's base 10. So log base 10 is pretty common. So when we see a log with no base, the base is 10. So that's log base 10 of 14. How about this one? Oh, we'd have 3 to the 5th times 4, which comes out to 972. This one, m to the 4th divided by n. Log base 10 of n to the 4th divided by n. And this one's just log base 6 of 5x. Once you pause the video, try these and then you can check your answers. All right, the first one you should have got log base 2 of 3. 9 divided by 3 is 3. Second one, log base 10 of 5 over 2 to the k. And the last one, log base 7 of xy over z. Pause the video, give these a try. Now this, oh, wait a minute. You're expanding this time, so you're going the other way. You've got a single log, you're going to write this as multiple logs. You're going to expand it out. That first one would be 3 log x, so the x cubed, the 3 can fly out to the front, plus 5 log y. Remember, the 5 can fly out to the front, and multiplication is addition when we deal with logs. If you haven't already, try those other ones. Second one, log of 3 plus 4 log of m minus 2 log of n. Third one, there's a lot going on there. Log base 3 of 7, we see that times 2 log, that should be base 3. The 3's not here. That should be there. Of 2x minus 3. That got left out of the slide. And finally, the last one. Log base 8 of 8 is 1, so that's why that says a 1. And then we've got a 1/2 power going on here. Log base 8 of 3 plus 5 halves, because we've got a to the 5 over 2 log base 8 of a. That's a tricky one. Here's a few more. Pause the video, give those a try. That first one, log base 4 of 5 plus 1/2 log base 4 of x. That second one, 2 log base 3 of 2 plus 2 log base 3 of x. We got the 2 on the front of both of these because it's 2 is to the second power and x is to the second power, and then we split the multiplication with the addition. So you're going to see a similar thing happen on this one with the half power. Half power becomes a multiplier in the front. We've got the 2 plus the x because they're being multiplied, and minus the y because it's being divided. And this one we saw that one of our properties, it's just the opposite of log base b of x. We're going to evaluate these. So sometimes we put them together, sometimes we do them separately, but in the end we try to get one number. So log base 2 of 4. 2 to the what is 4? Well, that's 2. 2 to the what is 16? Well, that's 4. And 2 minus 4 is negative 2. See which way we're going. We're going down. Okay. Log base 10 of 1 is 0. Log base 10 of 100. So 10 to the what is 100? That's 2. 0 plus 2 is 2. This would be 9. So log base 3, 3 to the what power is 3 squared, that's 2. 3 to the what power is 3, that's 1. 2 minus 1 is 1. Let's see, I can't do log base 6 of 4, and I can't do log base 6 of 9. So I'll multiply it together, get log base 6 of 36. So 6 to the what is 36, that's 2. This is square root of 1. Let's see, that's 1. So 5 to the what is 1, that's 0. And I've got 5 to the what is 5 squared, that's 2. So 0 minus 2 is negative 2. Up here, 3 to the what is 3, that's 1. 3 to the what is 3 to the 5th, that's 5. 1 plus 5 is 6. Here, 8 to the what is 16. I can't do that, but I can do 16 divided by 2 is 8. 8 to the what is 8, that's 1. 9 to the what is 1/3, that would be negative 1/2. And 9 to the what is 27, that's a tough one. So let's go back and try this. 1/3 times 27 is 9. That's 9 to the what is 9, that's 1. Here's a bunch for you to try. Go ahead and pause the video, give those a try, and then I'll show you the answers here when you press play. Okay, here are the solutions. I'm not going to take time to talk through these, but if you want, you can see me in class or whatever, and we'll go over some of these on paper together, you and I and whoever's in your group. That's our target for today. I'll see you in class.